Recording. Share my screen. And so today we have a handful of things to go over, sort of three topics. First one is talking more about the lab that did on Friday and over the weekend. Then we have the quiz that will be on Wednesday that we still have more material about that to finish up. And that might take up all our time doing both of those two things. But if not, then today we'll get into talking about this, using a little bit more Docker to talk about this Instagram tech stack and what your next homework assignment is going to be. But let me sit down. So I'm right now looking at the topic 3 folder, just push that up to GitHub today. And if you scroll down here, some quick announcements. So first one, all of your grades in Sakai are updated. A number of people have zeros in your grades, which is totally fine because the first things that we've had so far, for various reasons, I've said there's no late penalty. And so I will honor that. You can submit them the very last day of class, and I will not apply a late penalty. But you should just know that you are, if for whatever reason you can't do the problems, or we're struggling with those first 2 homework assignments, then you should think of yourself as definitely behind, and figure out with me how to get that fixed. Any questions about grades administratively?
I submitted the lab yesterday.
Okay. On Sakai, there's also notes in Sakai about why if you didn't get full credit, why that's the case, and so you can take a look at that and ask questions with me one-on-one whenever it's convenient, and I'll answer that if you have questions. The lab from Friday. My impression is that lots of people had lots of problems with the lab, and I did a quick spot check of submissions in Sakai, and there's about 20 submissions or so. I just looked at 5 of them, I think, and of the 5 that I randomly selected, none of them had correct answers. So probably if you've submitted already, you'll want to reevaluate your submission after what we're going to talk about here in the next couple minutes. Question?
Do we no longer get the 2-day extension?
Question A is about 2-day extensions. So we're going to talk about the collaboration policy here in a little bit, so we may as well just do that now. So the details of the collaboration policy, I've changed it this semester from past semesters. In the past, I gave people extensions for collaborating, and there was like no restrictions on how you could collaborate. I've restricted the collaboration policy a little bit this semester for 2 reasons. The main one is that I'm hoping this restriction is actually going to encourage people to collaborate a little bit more. That in the past, I think certain people, or lots of people, were collaborating very well, and that was great. But then other people having trouble meeting people to collaborate with, especially since we have people from all 5 colleges here. And so really what the fundamental purpose of this collaboration policy is that I still want you all working together, but I would like it to happen in one space so that anybody who wants to work together, which my hope is everybody, will know where they can go to find people to work with. So my hope is that you all work together on things. But you'll have to do it in the one space. The QCL was my initial idea of what that space should be, but I think, I don't know, over the weekends, maybe that's less convenient since it's only Sunday night that they're available. If there are other times that you would like that anybody would like to suggest as being like a group location, time, space to collaborate with, issue a pull request, and I will accept it. And I just want everybody to know about that, and everybody to be welcome to do that. The actual question, I guess, was a little bit more related to late policy. So with this lab and all labs, there's basically no extensions for any reason unless your hand got chopped off. It has to be something like super extreme to get an extension. So a number, I probably have a dozen emails from people asking for extensions. None of those extensions are granted. But again, what the late policy looks like is that you lose 2 to the n-1 points for each day late. So today would be 1 day late, so 2 to the 0. So losing 1 point for just 1 day late. And so like 1 day is not going to affect things at all, but this is exponential growth. And so if you delay significantly longer, then it will significantly impact your grade. But yeah, so there won't be extensions on the grade at all. And again, I mentioned this already, a lot of the current submissions are incorrect. And so I'd encourage you all to resubmit if after what we're going to talk about here in a minute, you think your submission is still incorrect. And in general, it's going to be a lot better to submit a correct assignment late than an incorrect assignment on time. Any questions about policy stuff before technical stuff? Yes.
I guess for the lead time, is it applied to the lab, like this particular lab, or does it apply to the overall placement? Like one lab is like 4 months. And then let's say if I'm like 4 days late for this lab.
So yeah, you're not going to go negative. That
Yeah.
that I guess after on an assignment worth just 4 points, after 3 days, then it no longer affects your grade one way or the other to turn it in. Most of the bigger homework assignments coming up will be worth 16 or 32 or 64 points. So the bigger assignments, then it would give you an extra day or two to work on it. Okay, so the problems with the lab, it was intentional, and so cue evil laughter. But why would I do that to you all? Why would I give you something that's going to have problems with it? Last Wednesday, we were talking about why do people use Docker, and the ultimate motivation for Docker is so that you can really easily deploy your programs, and you just write it on your computer, and it's going to work on the Lambda server, on AWS, Amazon, Microsoft Azure. You can wait 100 years and it's still going to work. And that's like the ultimate goal of Docker. But if you don't do things correctly, then the reality is that Docker doesn't really actually get you any benefits, and it's just an extra tool that can break. And so what we're going to talk about is, over the next probably 5 minutes, is first of all how to debug exactly what was going on in that the problem that was happening with that Docker container, and also how to, when you're writing your own things, how to avoid that sort of problem in the future, so that your stuff does actually just work. Question?
About the we get like some points off on the second point. Can you resubmit it?
The question is, can you resubmit assignments? And in general, no, unless I tell you otherwise, that it's just the one submission's what you get. I think for the some of the first assignments, I offered to let people resubmit for various reasons if I thought they, I don't know, for various reasons. And maybe in the future I might offer various reasons like that, but in general, no resubmissions. For this one, yes, it's fine. Okay, so in order to exactly see what the problem was, we're gonna jump over here to the terminal right now. Both of these windows, I'm logged into the Lambda server right now, and let's make them a little bit bigger so that we can see a little bit better. There we go. And here I make it big enough that this is like, I don't know, the prompt is just taking up my entire screen. It's super obnoxious. So recall that I can set the PS1 environment variable like that, and that tells me what my prompt is. PS1 equals $, like that. And so we'll just, and then I'll run reset again, reset. So now this is my prompt, easier to see, PWD, so they're both in the same folder right here. I have the Flask web folder inside of the The topic 3 folder, this Flask web folder is uploaded to GitHub if you wanted it or we're trying to follow along right now. The contents of this folder is just basically the contents of specified from the HTML file. This requirements.txt, Docker file, and app.py are all just copied and pasted directly from the HTML file. So you probably have a folder like this somewhere already on your Lambda server. And at some point you did something like docker build dot trying to build the container, and you got some nasty error message like this. And I'll zoom out just one more time. There we go. And so how can we figure out exactly what's going on here? The first thing to do anytime you're working with a Docker container and trying to figure out what's going on is to remember that you don't have to just modify the Docker file. You can actually directly go inside the container and run the Docker commands. And that'll make it easier to be more interactive with the Docker commands here to debug exactly what the source of the problem is. And so in order to do that, down here, I can run vim docker file, and we could start from the beginning. I could load up this container and then run each of these commands one by one. These commands take a little bit, it takes them like 10 minutes or so to run all of these commands because it has to download stuff. So I'm not going to do that. And I'll just do a real quick shortcut. And that's if we scroll up here, you'll notice that each of these steps that it's printing out corresponds to one of the lines in the Docker file. And there's a hash after every time one of these lines is successful, every time one of these steps is successful, there's a hash printed down here. And this hash is a Docker image. So it's something that I can run and start up the Docker container from that particular location. And so what I want to do in order to, this is the line that was failing, the pip install right here. That's the one that's failing. And so in order to get an interactive Docker session where I can just immediately run this line, I'll use this hash right here and do docker run -it and paste that there. And I do that and I'm put into this new prompt down here, and I'm actually inside the Docker container that corresponds to this hash. Again, up here on the top, if I run docker ps, we can see that there is this new container that's been created. And right here is my ff6 container ID. You can see that that matches right here. So this is in fact the container that I'm currently in. And I can reproduce the error message up here by running that same command of pip install -r requirements.txt. And if I do that, it'll get the exact same error message. Any questions about the setup of what I have so far here? Yes.
Wait, so was it in this case that the on step 609, is it the Docker image that is below that says it's running in, or is it the Docker image from the previous?
Great question. So this hash right here, it's the hash of the previous commit that, or the previous step. This is a successful hash, so I'm starting off at this location. This is where I started it. If I were to, Zoom's getting in the way a little bit here, but if I scroll up here, you'd see that the Docker run matches EFE, EFE. And now, did that answer your question? Cool. Any other questions about the setup? So fixing this problem. First, I'm gonna, let's try opening up the requirements.txt. You notice that I don't have Vim available in the Docker container. That's because I'm in the container right now. It's like a totally separate computer. It's not the Lambda server. It doesn't have Vim installed. So I'll just use cat instead to output the requirements.txt. And you can see that there's only one library down here that it has access to. If I were to come down, looking at all of the output over here, though, you can see that there's a lot of different libraries that it's trying to install right here. So there's this Jinja library, there's this WorkZug library, and eventually what it's actually failing on is this markup safe library. The problem is that markup safe 2.1.1 actually requires that we have Python 3 installed. And if I come down here and do Python -- version, you can see that this container, in this container, Python corresponds to Python 2.7. And so that's why when I actually run this command, it's giving me this error message because I don't have the right Python installed. So that's why I get a syntax error up here, because this is something you can do in Python 3, but you cannot do in Python 2. There's multiple ways that I can go about trying to fix a problem like this. Perhaps the simplest one is inside of the Docker file itself, change all the references from Python to Python 3. But by default, these all reference Python 2 in this Ubuntu image. And so changing it to work with Python 3 by doing things like just adding a 3 at the end of all the Pythons is one way to solve this problem. My preferred way to solve a problem like this, though, is to stick inside of Python 2, and we'll see how to fix this inside of Python 2. That's what I'll actually walk through. We'll stay with Python 2 and fix this in Python 2. And again, the fundamental problem here is that when I do cat requirements.txt, it's installing Flask, and it's installing Flask 0.10.1. So we have this fixed version of Flask installed, but this Flask library depends on other libraries like this markup safe library. And since there's no specific version of the markup library specified in requirements.txt, Python is free to try to install whichever one it likes, and by default, it chooses the most recent option. And so in order to fix this, we'll just go back in time to this tutorial was written, I think, in like 2018. So we have to figure out what were the versions of these libraries that were available in 2018 and install those versions instead of the latest version. Question? Question is, here I'm proposing walking through the fix of sticking inside of Python 2, but if you were to do some other way of fixing the program to get it to run, would that still count as correct and full credit? And the answer is yes. For, in general, anything in the course, that the only thing I care about is the final outcome of things. And so do whatever you think is easiest for you and makes the most sense for you. For me, the thing that's easiest and makes the most sense is sticking inside of Python 2. So that's what I'm going to do. It's also going to give us a chance to talk a little bit more about exactly the source of this problem. And again, the source is that the library we specified exactly must be Flask 0.10.1, but that depends on these other libraries like Markup Safe. Markup Safe, the older version of the library, worked in Python 2, but they've since updated that and deprecated the use of Python 2, and so now it doesn't work anymore. But good question. So the specific way to fix this is, so the constraints right here on the library versions that are listed are that we just have to install any, or the Flask library requires the worksug library greater than or equal to 0.7. So 0.7 is what it actually was originally built with, and that requires the markup safe library greater than or equal to that, and then so that's the version that it was originally built with. So I'm gonna just, down here, pip install worksug equals 0.7, forcing it to use that version instead of the newest version. We did not get an error message here. And so now when I try to, we'll just type it in manually again, pip install Flask equals 0.10.1. Still getting this error message down here, so let's try updating a different one of these libraries. So now it's talking about Jinja 2 here, so I'll just pip install Jinja 2 equals, what number did it say? 2.4. And so now that one installed successfully. Retrying to install Flask. And there we go, finally got something that worked. So we just, by changing, basically adding a command between this and this down here, or between this and the actual pip install command down here, so that we installed some previous versions of the packages. Then we got packages that actually work. And now if I were to move on and actually run the other things down here, the web server will run. Question? Yeah, so question is, so we've talked about the from and the run line. What exactly are some of these other lines doing? The maintainer line right here, this is basically just machine readable documentation that if we were to try to distribute this, this Docker file to other people, it just tells them who wrote the Docker file. So I guess I did edit this line, not directly copy and paste it from the web page. The copy, again, copying things from the Lambda server to the Docker container. So that's copying from the Lambda server to the Docker container. Workdir is just like the CD command. By default, the working directory is just the root folder. Workdir makes this entire thing the working directory. And then the run command, copy command again, entry point, and the command down here. These are more or less synonyms of each other. But it means that this is the command that gets run when you actually run the image. So this will actually run the app.py Python file. Did that answer your question?
Yeah, so there's not really like having that in your mind or not doesn't.
Yes, this has no effect on the actual resulting image other than a documentation effect. Yeah.
Does this solution solve it for every time you want to run Docker build, or is it just for this?
Yeah, great question. So here we're doing things in an interactive session. So if I were to leave this session and come back in, run the Docker build, then Docker totally forgets about all these commands that I've ran, and so it will fail. It won't run anymore. In order to fix that, in order to make it actually work, you have to somehow get the fixes that you've made down here, update them so that they work, so that they're incorporated somehow in the Docker file. With Python fixes like this, the standard way to do that is not to modify the Docker file at all, but to modify this requirements.txt file so that it now contains the new libraries and their new versions. The standard way to generate a requirements.txt file, and this is the thing that the tutorial author did not do, that really should always be done, is that down here you run pip freeze. Running the command pip freeze tells you like what are the actual versions of everything that is currently installed. And so if you use this as your requirements.txt file, then it's guaranteed to get exactly the versions that you want it to get, exactly versions that you know are good, and not try to get like the latest version of this or the latest version of this that might not work anymore. Yes. Yeah, so in this particular case, you run pip freeze after you are have gotten the build working again. In general, you run pip freeze whenever you need to get like the exact versions of the Python files that you have, or the Python libraries that you have installed. And that gives you, this is the correct way to generate a requirements.txt file. Anytime you need to generate the requirements.txt file, you generate it with the pip freeze command. Yes.
So I'm seeing that then was generated straight into the Python file, or now we have to add it in there ourselves.
So yeah, you do something like pip freeze requirements.txt like that. This is only going to save it onto the Docker image the way things are set up. So yeah, I don't know. Somehow you have to get this into the folder that contains the Docker file. So copying and pasting it's easy enough to do. But yeah, this has to be in the on the Lambda server in the requirements.txt file here, the one that's with the Docker file, not the one inside the Docker container, because as soon as I exit out of this and come back in, then it's not going to have that file anymore. Yeah. Question is there any meaning to the order in the requirements file? And the answer is no. yeah, the pip freeze just does it in alphabetical, but Python pip, when you do the pip install requirements, it will first load everything up and then figure out what's the optimal order to install everything and then do the install. So the order doesn't matter. Any other questions about anything related to the lab? Yes.
Can you just go over like, when you do like the port forwarding, how you have like one port and then the other port, like which?
Yeah. So let's see. The question is about port forwarding and setting that up. I'm going to, so I just ran reset in both the terminal sessions up here to get myself a clean new session. And one of the things that the next homework assignment is going to introduce is this thing called Docker Compose. And Docker Compose is going to automate for us things about setting up the port forwarding and other things that are kind of obnoxious to do. So I'm just going to talk about the setting up port forwarding with Docker Compose, and I think doing that will answer the question that you asked about more generally setting it up. With Docker Compose, if we scroll down in the notes here, I'll just do a Control F, Docker Compose down here. We'll go over that later. This is the important part that I wanted to highlight is that Docker Compose is a Python program. And so if you just try to run Docker Compose without installing it, you'll get errors. You first have to install it. And so you might have to run some other things in order to get it installed. But this is the final command that you'll need to run in order to get it. And if you run this command and it looks something like this, then you know things are working. Also, you know things are working because if you do Docker Compose and it doesn't give you an error message but gives you help, then you know things are working. And before setting up the port forwarding here, let's just first remind ourselves that if I do docker build dot here, our program is still going to break because I still have the bad requirements file. And so I'm just going to get rid of my current requirements.txt file and put my fixed version of the requirements.txt file in its place. So move requirements.txt into requirements.txt.original, and then move requirements.txt.fixed into requirements.txt. And now if I do the docker build dot, everything should run successfully. And now we can think about actually setting it up, the port forwarding and getting the web server working. Yes, question? The question is, if it was able to build, should you then be able to do the port forwarding? And yes, the important thing here is that you are that everything is built right here and everything's working. And many possible ways of getting it to that point. Another reason, actually, though, why I prefer the version 2, sticking with the Python 2, is you notice that I didn't have to make any changes to my Docker file, and I only had to make changes into that requirements.txt file. It feels somehow more like the change that I made is less small, since I only had to change a more auxiliary file and not the main Docker file. Any questions? Yes.
Is the it's dangerous zero? What is that? I saw we talked about the Ginger.
Oh, so there are lots of different files or lots of different libraries that Flask depends on. That one, it's dangerous, is it's dangerous to go alone. If you've ever played the old school Nintendo Zelda game, then this is the very first, like one of the first screens in the old school Nintendo game. That's where the library comes from. It's just a set of tools that for working with web servers. And so we're saying it's dangerous not to use this library.
Is it known after distribution found error that they couldn't find the library?
I'll have to take a look at that later. Not sure. Were you running the pip command and it said that?
No, it was after modifying the requirements.txt and trying to run it. It still says that they can't find the inside files. It's dangerous because 0.0.
Then you probably have a typo. Yeah, you probably did not use the pip freeze command to generate it. One way that you might have a typo is you using the single equal sign instead of the double equals, or there's just a typo in the it's dangerous thing somewhere. Okay.
Docker PS this, can I just see that?
When I do what?
When you do Docker PS.
So I'll do that up here. So I ran Docker build down here. So all Docker build does is it compiles the Docker file, makes it so that I'm ready to run a container, but it's not actually running a container yet. In order to generate the container, we'd have to down here say something like Docker run, and then we have to tell it which container to run. We use the hash of the output that we want it to run. So again, there's many hashes output down here corresponding to the different stages of the build. And we want the very last one of these hashes corresponding to, it contains everything inside of it. I do that. And if everything's working successfully, you'll see this output down here, which is the output of the Flask web server. At this point, we haven't done the port forwarding, the thing that we were trying to figure out how to do. So there's no way for me to connect to this web server, but the web server is in fact running, just can't be connected to. If doing Docker run like this does not work for you, it's generating error messages, then it means that somehow there was a problem with your build step. Control C down there exits out of it. So now we're going to set up the port forwarding and talk about this Docker Compose at the same time. This file right here, every project from here on out is going to have one of these Docker Compose files inside of it. This first project from last week only had a single Docker file inside of it, and so you could conceivably run all the Docker commands manually, but as you're adding things like port forwarding, those Docker commands get really long and awkward, very easy to make mistakes. The assignment for this week, I think, has 4 different Docker files inside of it, and trying to run those Docker commands manually is very tedious and error prone. And so the Docker Compose file is basically a specification of what Docker commands you should be running to build up the project. This extension over here, YML, is pronounced YAML. So this is the dockercompose.yaml file. I'm going to open that in Vim, and the build. So there'll always be a line up at the top saying the version. That's never going to affect us. Then services, the particular service that you're creating here is a web service. The build right here is the folder that you use when you do docker build dot. So docker build dot, that dot corresponds to that dot right here. This is the location of the folder that contains the Docker file. Folder that contains the Docker file for this server. And then here I have some ports specified right here. And these are I forget exactly what the port flag is. I think it's maybe -P. If I do man Docker, again, you can always use man pages to find references for things. Oh, man Docker build. Nope. Okay, I guess I don't have the man pages installed. Let's do docker -- help. Here's all the outputs here. Docker build -- help, and I'm gonna pipe grep for ports. Oh. P. Nope. Okay. Well, I think it's -P. We don't need to necessarily look into the details right here, but this is the, there's some flag and then you specified something like some number colon some other number. Anytime with these ports or anything where you're specifying two things on any terminal command, the mnemonic is that the first thing on the left is the thing that is closest to you somehow, and the thing on the right is the thing that is farthest away from you somehow. So here, the thing on the right, the thing that's farthest away from us is the Docker container itself, because the Docker container is inside of the Lambda server. In order to get to the Docker container, we have to go through the Lambda server. So the Lambda server is closer to us and the Docker container is farther away from us. The right number over here, 5,000, is the port onto the Docker container that will get opened. And the left number over here is the port on the Lambda server that gets opened. Flask by default always runs on port 5,000. And so this thing to the right over here is going to be 5,000 because we haven't changed any of the Flask code specifying that to be something different than 5,000. This number on the left, again, is the Lambda server port number. So I'll just make up another number right now. The 3400. 3400 is the port on the Lambda server. Down here, in order to actually bring this service up, instead of running the Docker command, I'm going to run the Docker compose command, and it's just Docker compose up. When you do Docker compose up, it'll automatically build for you all the Docker files that you have in your project and run them with the appropriate commands to get your port forwarding and other features enabled. So here we have port forwarding command over here. Again, the 5,000 is what's on the container, and the 3,400 is what's on the Lambda server. If I come down and look at the output down here, here's the IP address, the URL that the Flask server is listening on. You can see there's a 5,000 over here. This is the thing that is farthest away from us. It is in the container, not on the Lambda server. So this 5,000 right here, that has to match this 5,000 right here. And this is a number that everybody can reuse over and over again because everybody will be creating their own different containers. And so you'll have your own different 5,000s matching everywhere. The thing on the left, though, this is on the Lambda server. Everybody shares the same Lambda server. So this number has to be unique for everybody. So I have 3,400 over here. And so nobody else can use 3,400. I'm going to do :WQ, save and exit out of that. Actually, down here, I'm going to press Control-C to stop it, up arrow to rerun it. And I just didn't know if I'd saved it before rerunning it. So I want to save it again. And then up here, I'm going to do Docker PS. And you can see, I'll zoom out just a little bit more. There's some information under the ports about what ports are forwarded over here. That it says port 3,400. Again, thing on the left close to me. So on the Lambda server, forwarded to port 5,000 on this container, the thing that's farthest away from me. 3,400 to 5,000. In order to actually connect to this web server from Firefox now, I have to connect to the Lambda server with port forwarding. So I'll press Control-D up here to log out of the Lambda server. You can see I'm back on my own laptop right now. Press the up arrow to get back to my SSH command and add the -L for the port forwarding over here. I'll do 8080:localhost:3400. Again, the thing that is on the left is the thing that is close to me. So this is the number on my computer that I'll be accessing. The thing on the right is the thing that's farthest away from me. The thing on the Lambda server that I'll be accessing. And hit enter. And now if I come over to Firefox and connect to that, it didn't work. Somewhere I broke something. So down here, it's saying that open failed, connect failed, connection refused. Running on Control-C. Let's make sure that I have my numbers correct. Docker compose.yaml, 3,400 mapping to 5,000, 3,400 mapping to 5,000. I think that's what I typed in up here. 8080 to 3,400. Okay, that looks fine. 5,000 right there. Let's try it again. Bring it up. 5,000. Refresh. Connection was reset. I think I might. What? So good debugging up here. If I do the curl, so inside of, so let's bring this up for a second. And so now we have port 3400. Let's see. So the suggestion is something like curl HTTP //localhost 3400. So this is, I'm on the Lambda server right now, connecting to the Lambda server in port 3400. If I hit enter, hello, did it work? So this is in fact connecting to the remote server, and we're getting this message back. You can see down here that every time you connect to the server, Flask down here is outputting that somebody connected. And so that means that the problem with my connection can't be related to Docker. It has to be somehow related to the port forwarding. And I think the problem is actually that I have both of these two windows set up to port forward 3400. So this is, so they're interfering with each other. Control C down here, it's vim docker compose.yaml. Instead of 3400, let's do 5500. Save and quit that. Docker compose up. Retry up here 5500. Okay, that is working. Exit, up arrow. Change that to 5500. And now come back over here, refresh. Connect failed, connection refused. 100. Somehow my port forwarding is localhost 5500. It's supposed to be lowercase. I don't think it is, but I'll try it. And yeah. Well, as you can see, that very easy to not have things go according to plan and not have things work. I want to make sure that we have time to finish talking about the quiz stuff. So we're going to switch gears to do finish up the quiz material for this Wednesday, and then come back and either finish debugging this later or fix it, figure out what the problem was on Wednesday. But yeah, so we're going over this POSIX shell 2 notes right now, and I just want to make sure that we finish this before Wednesday. There's not too much left for us to go over. Last time we sort of talked about this section 1 up here, but we'll talk about the rest of these sections today. We're talking about if statements inside of the shell last time. We're going to finish up talking about other conditional related things today, and we'll see how those relate to the Docker file. Reminder, so let's see, I'll move that here. The statement for if statements in Bash, we have if, and then the square brackets, something like this, then a condition. So like test equals test, then echo hello, and then else echo goodbye. The ending of your if statement is phi, like that. And so because these two things are equal, it's doing the if clause over here. And if I change this so that they're not equal to each other, then it'll do the else clause over here. We also saw that there's If you want to have ands and ors, then you put them outside of the square brackets. So something like that, and q equals q. And you have to have a space between your the square brackets like this have to not have a space, have to be surrounded by spaces. There's that won't affect things on the quiz, but that'll come up while you're doing this in the real world. Any questions about the if statement syntax stuff before we see the more complicated things? Yes. If you have an error message that says something like test not found, there's lots of ways that you could get an error message like that. One of them is if you do not have square brackets, or you just have something like if test. This is likely to give you an error message. Test is an actual thing though. Something like that. Command not found. Just means that you have a typo somewhere. That leads us into exactly what's going on right here in the if statement. And this will be the important thing. That what comes to the right of an if statement is just a general command. And it turns out that there is a command, and when I say command, I literally mean like a file on the computer that has execute commissions. There's a file on the computer called square bracket like this. And if you type which square bracket, it'll tell you where on the computer that's located. And anytime you do the if statement, then this is literally running the square bracket program and passing this information to the square bracket program as its parameters. So we could say something like test equals test like that. And that's a totally valid statement in the POSIX shell or in bash. This, again, just runs that square bracket command and passes this information to it. The square bracket command doesn't actually do anything except evaluate whether this is true or false. If we do something like add an and over here and run echo hello world, then the stuff to the right over here, this will only get run if the command to the left succeeds. If the command to the left fails, then this command over here to the right will not run. The and over here, what it does, it's sort of like the Boolean conditional ands that you're used to in like Python or other programming languages, but it's not exactly like that. That if the command to the left succeeds, it runs the command to the right. If the command to the left fails, then it does not run the command to the right. Similarly, or the opposite way, is that if you have the ors, what the two vertical bars do, is that if the command to the left succeeds, we do not run the command to the right. But if the command to the left fails, then we do run the command to the right. So ands and ors are, the reason they behave the way they do is so that they work in if statements like Boolean operators, but they're not the Boolean operators that they're used to. They're actually for chaining commands together in the Python shell or in the POSIX shell. The way that comes into Docker files is if we take a look at that Docker file again, you can see up here there's these double ampersands right here. And again, anytime you have a run command, the thing after the run command is literally just typed into a POSIX shell running on the container system. And so it first runs this command right here. And then only if that command succeeds will it go on to run the command that comes next. The backslash right here is a common idiom. It exists in every programming language. And the backslash, when you have a backslash at the end of the line, it means that that's exactly the same as this. Those two things are interpreted to be exactly the same. Backslash just means that don't treat the next new line as a new line, treat it as just a generic white space character. The mnemonic for remembering that is that backslashes are always used for escaping things. They escape whatever the next character is that comes next. And the next character that comes after the backslash is a new line character. And so if we escape the new line character, if we tell it that the new line character should not be interpreted as a new line character, then it'll put everything on one line over here. Question? So the backslash is always just used for readability purposes to put multiple things on different lines to make it obvious that these are like two different commands. Yeah. That's how to parse this. Two separate operators right here, and means that only run the rightmost command if this command fails. Backslash means that it's treated as one line. Good question. Any other questions so far? Okay. The Docker over here, it knows that one of these lines fails whenever the entire command itself evaluates to a failure condition. So we're going to see what it means to evaluate to a failure condition here next. There's a special built-in variable in the POSIX shell called $? And so if we say echo hello world, this command succeeded right here. And so if I echo $? We'll see that we get the value of 0. $? Always outputs what's called the exit code. So $? Stores the exit code of the previously run command. And $? of 0 means the program succeeded. Any non-zero means the program failed. So up here, when I do something like this, I run this command right here, the square bracket command, check is test equals test, and hit enter, and then echo $? I'm going to get a 0 because this command succeeded. It checked its parameters, these things right here, saw that this thing is equal to this thing, and so it has an exit code of 0 indicating success. If I change this so that these two things are no longer equal to each other, test equals TE, and hit enter, and look at the exit code, we'll see that we have an exit code of 1 to indicate that our command right here failed. And we know that because this special exit code variable right here has a 1 inside of it instead of a 0. When we look at the ands and the ors, the way they work, so stated differently than we said before, is the and will, if the command to the left has an exit code of 0, it will run the thing to the right. But if it has an exit code that is non-zero, it will not run the thing to the right. And the or command is the opposite. It will run the thing to the left. If it has an exit code of 0, it will not run the thing to the right. If it has an exit code of non-zero, it will run the thing to the right. So this has a non-zero exit code. Non-zero exit code. So that means that the or will in fact run the thing to the right. Hello world. The inside of a Docker file, where did the Docker file go? Inside of the Docker file, it's occasionally what you'll see happen is that people want to run commands that may fail. And so one example of a command that we might want to run that could possibly fail is like downloading something from the internet. So like a curl command, google.com. Downloading something from the internet can fail because the internet might be down or this web page might be down. If you want your program to definitely continue building though, after this command right here is run, even if it fails, you don't want Docker to know it fails, then you can add an or true at the end to this. This says that we'll try running this. If it succeeds, we won't need to run this at all. We'll just return a 0 exit code. If this does not succeed, then we will run this over here. The true program always returns a 0 exit code, and so this will return a 0 exit code, and this run command here will succeed no matter what. So this is a common idiom in Docker when you want to run a command and you don't care whether it succeeds or not, you still want to keep building the Docker file. And this is a common idiom. When you do care if things succeed, you want the program to break, stop compiling if any of these things fail. Any questions so far? We'll save that. So one more last thing to cover about if statements that will be on the quiz, and that's how you can combine if statements with commands other than the square bracket commands. The if statements, so again, the if statement, it doesn't care what command you put over here. The square bracket command is the most common command because that handles equality tests, and equality tests are very common. But you can put any command you want right here. So we can say like if echo test, then echo hello, else echo goodbye. And the echo test right here prints the test. It returns an exit code of 0 because exit succeeds. It did in fact print the test. And so it goes inside the then statement right here. There are other commands though that whose status code depends on the contents of what we pass in right here. And a very common one is the grep program. I'm going to go into a quiz folder right here. Let's go ahead and delete all of these things. And I'm just going to create a real quick file, test hello world, hola mundo, salve mundi, cat test. And we've seen this before, pipe grep the letter E, and we get these two outputs right here. Whenever we have grep as our command, grep succeeds, meaning that equals 0 if it has lines that match the expression. So this command right here, if we rerun it like that and do echo question mark, we'll see that the command succeeded right here. Gets a 0, means it succeeded because it did in fact output things right here. But if we change this to grep something that's not going to match like that, no output down here, and so we get a non-zero exit code. So it's very common to see things that look like if cat test pipe grep E, then echo succeed, else echo fail. Here we have these two lines are the output of this expression right here. The output of this expression right here corresponds to these two lines. The grep here did in fact succeed, so we get the 0 exit code. So the if is like it's evaluating to true. Go into the then clause and echo succeed, and that corresponds to this succeed right here. The else over here, if we change this expression to something that doesn't match any of the lines, nothing will be output right here, so grep will fail, and so we'll echo fail down here. So this is also another very common idiom you'll see with if statements, and in general you can put any command that you want right here, any long sequence of commands with multiple pipes, ands, and ors, and as long as that evaluates somehow to true or has a 0 status code, 0 exit code, then it will go inside the body of the then part, in the body of the if statement. Any questions about the if statements or anything about the quiz material? Okay, you had a question about?
Yeah, if we have like a Git repository, and in like the repository inside of, do we have to add every single thing inside the folder and add the folder itself and then commit, or can we just add folders?
Yeah, so when you're inside of a Git repository, in general, you can, so let's go to prod CMC here. And let's run git status. So I have a bunch of things here that I have changes, and I could manually go through and type git add of all of these changes individually. Or if I we'll say just reference this folder right here. There's 3 things inside of this folder, those 3 things. And that added all 3 of these things. If ever you want to remove things from here, git reset. Remove those like that. Another very common idiom when you want to add things, if you just want to add everything, saying git add dot. The dot here always refers to the folder that you're currently in. So this is just another thing like adding this entire folder, only it's adding all of the contents of all folders. Git add dot, git status, added all 4 of those files. Very rare actually for people to want to manually one by one add files to a repo, and usually doing something like git add dot is more common. Yes. Sure. Yep. Question is, how does the Docker PS relate to the debugging procedure for Docker build that we were talking about before? I'm going to, so I just moved 2 terminal windows here side by side. Reset, reset, cd topic 3, Flask web. I think they're both in the same window now. And anytime you run Docker build, this will never affect Docker PS. Never affects Docker PS. The only command that changes what gets displayed in Docker PS, the only command that changes what's in Docker PS is Docker run. Docker run is the only Docker command that affects Docker PS. The Docker compose up internally runs Docker run, so this will affect Docker PS. Down here, if we did the Docker compose up, you can see that so the surface is running down here. Now if I do Docker PS, it does in fact show that. Yes. Is it because if you're inside of Docker run in any way, then Docker PS will show that you're inside of Docker run. And let's see, so this brings us back to the port forwarding issue. Try to figure out what was going on there, debugging it, unless there's more questions. Yes.
Yeah, so during lab, the part that you
During the lab period time, I had a web server running on port 5000, and then after the lab period, that web server was closed. So if you were trying to reconnect to that web server outside of the lab time, then it that's why you weren't able to. Okay, I'm going to figure out what is going on with this port forwarding, and hopefully we will fix that, and hopefully that will help you all complete the lab and this subsequent programming assignments. So I'm gonna talk through all my thought processes while I'm doing that. So right now I'm just opening up the Docker file, reminding myself what the ports are that we have over here, 5500 over to 5000. Down here I'm looking at the Docker up output, Docker compose up, and it's on port 5000. We were looking at before curl of localhost colon, so 5,000 is not going to work because the 5,000 port is the port that is on the container. Instead, it was localhost 5,500. That did in fact work. We can see the output coming out right there. Forget if I had the port forwarding going. There's our port forwarding command, 8080 to 5500. That is good. And let's rerun that curl command. It did work. I'm going to open up another terminal window on my laptop over here, and let's try using curl to browse that. Empty reply from server. Connection open failed, connection refused. Empty reply from server. If I change that to a different thing, we'll see it's a different thing. Open failed, connection refused. Okay, connection refused. Great question. The question is, what would the error look like if somebody else was already using that port number? And that error would happen during the Docker Compose up phase down here. That at the Docker Compose up is when it tries to allocate the topic 3. That's why I'm just opening the Docker Compose. At the Docker Compose up, when you run this is when it actually tries to allocate these ports. The 5,000 port on the right, that should never be a problem because that's again on the container itself. And so everybody, every time you run this, a new container is created. So everybody will have their own container. And so that shouldn't matter. If this number on the left here conflicted with somebody else, then down here it would give us an error message telling us that it somebody else is using that port number. And so we know we're not getting an error like that because that this is actually running down here, and also because when we're on the Lambda server, we can do that curl command and actually connect to the web server. Empty reply from server. Let's see. There was also, so that in, let's see, I don't have it specified, that netcat command that I could use to try to debug things. Popping up another web server real quick. Where did it go? So the terminal-based web server, let's just copy and paste that. Right here, my port number will be the 5500. So here we're getting that address already in use. Echo. Hello. Here we run that empty reply from server. Empty reply from server. It is because I was doing the double port forwarding and I was double allocating the 8080 was the problem. This should fix it. CNC 143, topic 3, CD Flask Web, Docker Compose up. Errors. Listen, bind address already in use. If I run, so let's do PS1 equals $, like that. So down here, if I run Docker PS, Docker Compose down. So saying that the address was already in use, Docker Compose up, bring it back up. Account errors will bring up the project, Docker Compose.yaml. There we go. So I'm listening on 5501 up here, down here, connect 5501 up here, curl, hello, did it work? Back over here, refresh, hello, did it work? And it all did in fact work just in time for the end of class. So the problem that I had was that I had two different port forwarding sessions going at the same time. And so it was trying to, was getting confused about which one it should connect to. And yeah, unfortunately confusing, but hopefully somehow that was maybe useful to you, and hopefully that answered your original question somewhere along the way today about getting port forwarding working. If anybody has any other questions about anything, happy to stick around afterwards and answer them. I have office hours now as well if you have longer questions. But otherwise, that's it for today.
So the port that exposes is the first one.
Which part are you talking about?
Just on in the lab like description. You
Um,
said
So just me, there's like, so there's multiple times when there's first and second. So here's in the SSH command where there's first and second, and then in the Docker compose.
yeah.
Um,
So there,
So this is on the Lambda server, this is on the container, this thing on the Lambda server has to match this thing right here. As long as those two things match, then you're good.
Cool.
And then this is the thing on your laptop, so you do localhost :net. This is the thing on the Lambda server, this is the thing on the container.
and then you do office hours here in your office.
I'll go up to my office.
I was trying to reinstall, like, I think I reinstalled like the Docker package twice. So like I checked the